everyone, and welcome to this webinar on the AP Computer Science Principles with Microsoft MakeCode curriculum. In this webinar, we're going to cover what is the APCS Principles course, what is Microsoft MakeCode, and then we'll dive into the curriculum, showing the scope and sequence, as well as some example lessons. And then we'll also go over the pedagogy behind the course, and then finally end with some resource links where you can get access to everything. But first, let's go ahead and introduce ourselves. All right, so Kelly, I'm going to hand it off to you first.
Yeah. Hi, I'm Kelly Etheridge, and I teach at St. Paul's Episcopal School in Mobile, Alabama. I'm the Director of Teaching and Learning, but I'm also an AP Computer Science Principles teacher and Design Thinking teacher. So just have a couple of hats at the school.
And Kelly is also the author of this curriculum. And I'm Jacqueline Russell. I'm a program manager on the MakeCode team here at Microsoft. And I was also Kelly's assistant in writing this course. So I fetched her virtual coffee.
Definitely.
All right, Kelly, so I'm going to hand it off to you to talk a little bit more about what is APCS Principles.
Yeah. So AP Computer Science Principles is an advanced placement course administered by the College Board in the United States. The course is offered in high schools and is considered to be the equivalent of an entry-level college course for non-computer science majors. So it's open and broad enough for anyone who's interested just a little bit in computer science. Depending upon the college, students can receive college credit for the course if they take the AP exam and meet certain requirements. Typically a score of 3 or higher will get that CLEP score. The AP Computer Science Principles course was developed to create leaders in the computer science field and to attract and engage students who are traditionally underrepresented in the computer science courses. Last year, 114,000 students took the exam, making it one of the most popular AP courses that the College Board offers every year, which is amazing to me that it's grown so much. Yeah.
Yeah, and I love seeing these charts around the diversity of types of students that are taking the CS Principles course.
Yeah, and that has increased more and more every year as well. And so there's a big push for even more diversity.
That's great.
Yeah. The goals of the course, AP Computer Science introduces students to the foundational concepts of computer science and challenges them to explore how computing and technology impact the world. Within the course, students learn computer science principles, how to code and analyze code. They'll also explore computing innovations and their impact on society. They develop programs that address real-world problems and collaborate in the development of solutions to those problems. Collaboration is a really crucial part to this, working together and helping each other and coming up with solutions.
And you wrote a lot of sort of group or pair programming assignments and projects within the curriculum too.
Yeah.
Great. Okay. Well, thanks, Kelly. I'm just going to talk just a quick little bit about Microsoft MakeCode and what it is. So MakeCode is a free online learning platform that teaches computer science. And our vision is to inspire new generations of technology creators with fun, inclusive, and accessible learning experiences for all types of students. So MakeCode has both a visual sort of drag and drop block-based coding interface, as well as text editors for both JavaScript and Python programming languages. Sounds like a train over there, Kelly.
Shifting class.
Nice. So MakeCode supports physical computing devices like the microbit this year, as well as games like Minecraft. But the version of MakeCode that's used for the APCS Principles course is called MakeCode Arcade. And that allows kids to create their own arcade-style video games. And so if you're interested in learning more about MakeCode, you can go to aka.ms/MakeCode. All right, so what's that?
The kids love it. It's a great platform.
Kids love video games, yes, and creating video games is a lot of fun.
Absolutely.
Alrighty, so let's go ahead and dive into the curriculum. Kelly, you want to talk to us a little bit more about this curriculum?
Yeah, so the curriculum is endorsed by the College Board, which is great because that means that you ultimately have everything packaged and you have a pre-designed syllabus, pre-approved syllabus that you can submit for your course audit and use everything and know that you have prepared. To receive this distinction, the curriculum had to align with the curriculum framework standards established by the College Board and cover every learning objective in the course. Because the curriculum meets every learning objective, you know that your students will be well prepared to take the AP exam and at the end of the year. It spans a full academic year for high school students with a 45 to 50-minute class period. But of course, if your classes are block schedule, which means you only have your students for a semester, the curriculum can be modified to fit that schedule as well. It's completely free and open source, so you can make adjustments to it. You have the right and ability to take the documents and modify them to fit your students' needs and what works best for them.
So Kelly, so when you say the curriculum materials are free and open, so we know that College Board and the AP Computer Science Principles course is a US focused organization and course. But right. Could educators from other countries also take these curriculum materials and teach it not as part of the CS Principles?
Absolutely, yes. So, you know, there's a lot up until Unit 7. There's really, it's all just content and references to the AP exam, but it's not AP centric. And then when you get to Unit 7, there is, of course, some focus on the AP exam, but it's still a great project and great activities for students to do to apply what they've learned. So it definitely translates, even if you're not using it for AP Computer Science Principles, College Board of the United States, to use it at your school.
Great. All right, and then so how do you think this course is different from, because there are other computer science principles curriculums available. How do you see this course as being different from those ones? Yeah, so it's free. I mean, there are other courses that are free, but not all of them are free. So one differentiator is, of course, that it's free and web-based, and a couple of formats for optimal flexibility and accessibility, which we'll talk about more later, but there's a website, and then there's also PowerPoints, Word documents, and a OneNote notebook if you use OneNote. And so you have the ability to distribute that information really seamlessly, however it works best for you and your students. And when you say web-based, you mean like all of the tools and things, like there's nothing to necessarily download and install, right? Absolutely, yes. There's nothing to install. So the coding is web-based, the content is web-based, everything is there, that if you don't have any access to download, you can just use it all online. Absolutely, yeah. Right. And then the programming units use MakeCode Arcade, which engages students because it's as Jacqueline already said, it's a retro arcade style game and the students love it. They have fun making different games, and even just the little activities of an algorithm that adds numbers, you know, they have a sprite that they can use with it and different things to make it more engaging and creative. And that ability to use either block code, JavaScript, or Python. You have students who are in the class who've never been in a coding class, and this is their very first experience, and that block code is really helps them. It's not intimidating. And then you have, of course, the JavaScript or Python for those students who are more advanced and have taken some coding classes before. It's project-based, so it's really, yes, there's guidance and there are certain things you have to do to meet AP requirements, but the activities that the students do are project-based, which allows them to choose that voice and choice. They get to choose the project that they create. They get to access it in a way that they want to, and it allows them for their unique creativity and their self-expression. And then I don't know of another curriculum that has a service learning component like ours does. So
great that you can have this. We've learned all this information, and now let's figure out how we can use it to impact our community and our world. And so that service learning with the games for social good and looking at SDGs, we'll talk about it a little bit more later, but there's a lot of great in that as well. And then, of course, definitely written and tested by an AP Science Principles educator.
That's right. So your kids went through like all of the lessons that you wrote, right?
Yeah, and we modified a few as we did, because they were like, no, that doesn't. But for the most part, it was they loved it and responded well, and so we made minor tweaks and discovered things as we went along. Yeah,
that's great. That's great.
Yeah, so the content, so just to give you an overview, is centered around 5 big ideas, and these ideas are cross-cutting concepts that build conceptual understanding and spiral throughout the course. So within the big ideas, they reflect what colleges and universities typically expect students to master to qualify for college or placement, and that's how the College Board picks them. And they serve as a foundation of the course and help students create meaningful connections among concepts. They're often overarching, so they thread throughout, and it was always great to go, well, remember in Unit 2 where we talked about, and now we're going to talk about it in this different way. And so they were like, oh yeah, didn't we say something about that? Didn't you talk about that last week? And even we were in a new unit. And so it definitely, but it always allows for that deeper conceptual understanding. So that emphasis and rehashing it in different ways is really great. And the 5 big ideas are creative development, which is the iterative and collaborative process of designing programs. Data, about how computers consume, transform, and produce new data. How they store data, and then how we as users can use that data to create new information, solve problems by interpreting that data. Algorithms and programming, of course, is all about integrating algorithms, abstraction to create programs for creative purposes and to solve problems. And then learning about computer systems and networks and how they work and how they transfer data. Students really like learning about the ins and outs of all that. And then the impact of computing is such an important thing for students to think about computing innovations, not only how they revolutionized our lives, but how we must act safely and responsibly while using the computers, and how computing innovations can be both beneficial and harmful. So we talk a lot about as if we're going to be future computer scientists, or we are as we're in this class practicing computer scientists, we really need to think about what we're doing and how it will impact those that experience it.
And I love in that unit, Kelly, one of the projects you have is a debate amongst the students. So you take like a topic like these COVID tracking apps, right? So you take a topic like that and you have the students debate one side against the other. So
yes. Those are very lively and engaging.
Yeah, no, it's fascinating. All right.
Yeah, so then with just the scope and sequence, there are 9 units. Of course, we say the service learning one is optional because ultimately time may run out, but generally a lot of people have time after the exam, and that's a perfect time to do it. But there may be that you have time before the exam that you want to do it as well. But it's builds, when they build on each other, those big ideas building on each other allows for the units sequence as they are. So the first unit really is introductory. We establish norms, we build community, they learn about design thinking and computational thinking, and they learn about the course content, expectations, what's going to, kind of a big picture of where we are now and where we want to be by May to accomplish the goals that we have for the course. And then Unit 2 is all about how computers work and how they communicate with one another. It really helps them understand how the internet works and how everything kind of works together. And then they're very anxious to start that coding quickly. So we get into algorithms and programming with a part 1 unit that's basic programming concepts, core game development constructs. And then we take a little bit of a break and do Unit 4, diving into both the beneficial and harmful effects of technology and crowdsourcing and digital divide and all those really important topics. And then we go back to algorithms and programming and coding in Unit 5 and get more advanced with our programming, learn about making code efficient, reusable, easy to understand, and then more advanced game development concepts and different things that need to be explored there. And then Unit 6 is about data and data science process. And they do a fun project where they do surveys and collect that information and then make infographics. And then as part of the exam for the College Board, there's a create performance task, which is students create their own program that meets certain requirements, and they have to submit it as a digital portfolio. And so to make sure that students are really prepared for that, there's a mock create performance task that you take your students through. And then after you've done that with them, then they are able, you set them loose, and you can't help them at all. And it's so hard, but you can't help them at all. And you set them loose and let them create their own project and answer the questions and meet those requirements. And then we move to focusing on exam review for the AP exam. Lots of practice through the College Board website with their practice questions and different things, and hash out reminding each other of different topics. And then our service learning project that allows them to create a game for social good.
Great. And we do have a web page, which is an overview of the course. And I'm just going to hop out here to show you, but it's at makecode.com/CSP. So I'm just going to open up my browser window here. So this is the overview page of the course. On this page, you can see we've got kind of just an overview of what the course is. There are some professional development opportunities and links to register, and I'll cover off on that a little bit later. But on this page, you can kind of go through and see sort of all the stuff that we talked about, as well as a very quick kind of course at a glance view of all the different units and what kind of topics they cover, as well as some just examples of some of the lessons in each unit here. So this is a great page if you want to kind of just get to know the course a bit better. All right, let's go back to the slideshow. All right, and you want to jump into some of these example lessons, Kelly, just to give everyone a flavor of the course?
Yeah, absolutely. Another AP requirement is that they have an activity called Explore Curricular Requirement. And it basically asks students to distinguish between computing and non-computing innovations, and then analyze how a computing innovation uses data as a potential data risk, beneficial, harmful effects, and privacy and security. And so it has to be done at least 3 times, and this is that a recurring assignment. It's in units 1, 2, 4, and 6, so you don't forget and lose track of how many times you've done it. But it just, they create a short analysis of a computing innovation for homework, and then they share it out to the class on a specific day. And they love to find new, and I encourage them to find new and emerging innovations to discuss those with classmates, because those, everybody knows about Spotify, and not that Spotify's not great, but let's see what else is out there and think about it.
Great.
And then another type of lesson that we do throughout the course is group discussion. There's lots of collaboration, and not only is there collaboration with projects, the debates and the different coding projects and such, but then just really getting them to talk to each other about different concepts, that uncovering of material and understanding rather than just talking at them. So here, for example, they're learning about the Internet of Things, and after we discuss the Internet of Things, we look at it in a real world, and they each pick a case study regarding an IoT solution, and they work together to analyze the case study and answer questions related to it, and then they share out with each other and discuss it more. And then, of course, there are programming units, which the kids love. And here's an example of one in Unit 3 where we're learning about strings and string functions and substring and concatenation. And so the parts of speech project, they create a game with two characters speaking to each other. Where the second character repeats only certain parts of the speech. And so not only we're getting a language arts lesson in there, but then of course we're also practicing those different tools and elements that they're learning. Yeah.
And what I love about, like, you know, assignments like this or projects like this is the sort of interdisciplinary nature, right? They do have to practice, oh, it's, you know, what are the nouns or what are the adverbs or what are the pronouns in this, and then use computer science to pull those out. And I'm just going to jump over here really quick, Kelly, and actually show folks this, this programming example. So this is like the mod. So in a lot of the programming assignments that Kelly does, she'll give the baseline programming assignment, but then there's also an extra challenge or a mod that students can do in addition. So this is a mod on that parts of speech one, where the challenge was to, hey, add more sprites with more different types of parts of speech and see if you can pull it out. So in this case, it's, you know, this is the sentence up here. The pink princess is saying the castle is cold in the winter, which is why we build fires. One of the sprites is pulling out verbs, one is pulling out nouns, and one is pulling out pronouns. When I press A, yeah, they pull out all of the right parts of speech from the original sentence. And if I just go into the code here, you can see that students build the code either in blocks, or alternately, they can also code it here in JavaScript or in Python. So they can sort of decide.
Yeah, and that choice is so great to have those options. And then, as we've been teasing about, talking about this a number of times, it's come up, that in the curriculum, because it's centered on project-based pedagogy, there's this service learning unit. It's a great example of that PBL focus. They select one sustainable, we learn about sustainable development goals, and then they select one of those goals and they build a game aligned within that theme. And so they drive the project completely by choosing their SDG and what type of game they will create, and then how they will then market it and get it out into the world for people to play. So it's super fun. We talked a lot about how we really have this as a project-based, but important also to know that this is designed for teaching teachers with very little or no prior computer science experience. So that means that ultimately everything that you need, all the solutions, all the mods are there for you, and also that it's created in a way that is more open-ended with those project-based learning to give that ability to create and be more flexible. They're a mix of open-ended projects, coding activities, and reading and journaling responses. There's rubrics and solutions provided for all activities just to give it to you and be help. All right, I think we go on the next slide. Yeah, so of course we've talked about the fact that this course in particular is designed to attract a greater diversity of students to the field. And even though the course is open enrollment, there's a lot of kids who have a misconception about either computer science classes because they've never taken one, or AP in general. They're just, oh, I'm not smart enough, or oh, that's just going to be too hard, or I'm not techie geeky, I can't do this. And so it's really important for you to become a marketer, help encourage your students to take your course, so that you have that diversity and inclusion. Inviting them personally, talking to clubs or sports, or having, if y'all have like a elective fair, having something that shows it. Sharing the information with parents is always a good one. Letting them know that there's a great course that their kids can take, even if they're not traditional AP students in their mind. Of course, you want to create a culturally responsive classroom that is inclusive and safe. It feels like a safe community for your students. And those strategies are numerous, but definitely peer mentorship and creating that just sense of community at the beginning where everybody has a voice and they all are honored and they feel capable and confident to speak up and ask for help is always really important. And then there's lots of diversity and inclusion resources out there. AP Central has a whole page dedicated to it. Microsoft, of course, has resources as well, and National Center for Women in Information Technology has some resources that we'll be sharing at the end. The course materials are everything you need. So there's an educator guide. We talked about it being web-based, online, and Word documents, PowerPoints, and in OneNote. The PowerPoints have slide notes or notes in each slide. So you have talking points and literally you could just read off the slide if you wanted to. So detailed notes for you to use in class. There's at the beginning of every unit, when you go to the OneDrive, there's a unit overview video that tells you what's going to happen in the unit, what materials you would need. So on day 5, if you need a deck of cards, you're going to have that. So you can go ahead and get those supplies ready and prepared. And ultimately just kind of a quick overview so you know what to plan for. And then of course you have a day-by-day lesson plan for each day. Blown to Bits is the textbook that's connected to the course, and the kids love it. I mean, I thought, ooh, they're not going to like to read. That's going to be the one thing. And they're like, this Etheridge, that was so interesting last night. Do I need to read the rest of the chapter? No, I didn't. Oh, can I read the rest of the chapter? Of course you can if you want to. So it's a really good book, and it's free and accessible online. So that's what's so great. Again, it's all open source. It's all free. You don't have to download a thing. It's just right there for you.
Great. And I'm just going to jump out real quick, Kelly, and kind of just show the course materials online here. So, this is where we've kind of posted the bulk of the course here online. So you've got the different units and an overview of each of the units, the big ideas, all the materials that you would need for that unit. And then, of course, each day you can go through and, see what are the different parts of the day, the different assignments, the different readings that the kids need to learn. So all of this is posted online. And there is a OneDrive that all the materials are also available as files, right, if you want to download. So these are the unit overview videos that Kelly was talking about, which kind of just give you an overview for each of the units before you jump into them. And then this is where you can kind of dive into all of the files. So again, all the PowerPoint files, all the Word document assignments, or the PDF reading assignments for each of the units. So all of these materials, as well as the course syllabus is listed here, but all of these materials are available here on the OneDrive. And this is the OneNote version. So we have the online version, but there's also a OneNote. So if you use OneNote in the classroom, it's a really nice way that you can kind of, get to all of the course materials. And if you use the classroom notebook, right, Kelly, you could actually use this with your kids. And there's all of the websites. So it's a really nice way to kind of see all of the different parts of the course. Kelly, did you want to talk a little bit about how the format of this, or?
Yeah, the train came by again. It's time for lunch to stop, but so it's basically organized by unit and then by day, and then you'll see that like on day 5 you've got that summary page right here with all the links to different PowerPoints and such. And then if you go down to the bias algorithms page, you'll see that that's a handout that you want the students to to do. I think this was, an article that we wanted them to read. And so if you do use OneNote Class Notebook, then you can download this as a read-only notebook, and it becomes your master notebook, and then you can distribute to the class notebook right into the students, the content library, and right into the students section. So it's really nice and great. But that first page has an outline for the day, the details break down by the minutes, your essential knowledge, everything that's kind of covered there. And then all the resources that are applicable either link out to a PowerPoint deck, or if you're not a OneNote user, then there's a link out to a Word document of that exact same thing. And then, of course, the OneNote pages as well.
Great. All right, let's get back here. Okay, so let's talk a little bit about professional development. So there is a 5-day course that supports this curriculum, where the first day is really asynchronous learning pre-work. So it's really 4 days of instructor-led training that's going to be delivered virtually and is free this summer. You must be teaching computer science principles in the fall, though, to qualify. So we've got 3 sessions scheduled for this summer. June 14th through the 17th, which is sort of those 4 full days of instructor-led training. And then we also have another session that's just 1 day a week. So it's 4 weeks, but just 1 day. I think it's the Tuesday. And then the third session is part of the Infosys Pathfinder Summer Institute, which runs July 18th through the 23rd. So if you are interested in teaching CSP using this curriculum in the fall, please do sign up for one of these professional development sessions. You can sign up at that overview page that I showed you at makecode.com/CSP. The other thing I wanted to call out is that we will have sort of an abbreviated online version of the course available on the Microsoft Educator Center soon. So keep your eyes out for that. All right, and then in terms of community forum and support, so for educators who are teaching with this curriculum, there is a forum that is available and we monitor it regularly. So if you have any questions or comments as you're teaching the course, please post them in the forum. And we are especially interested in getting your feedback, as this is a fairly new curriculum. We are interested in improving it and constantly making tweaks to make it better. So, so definitely let us know your feedback if there's things that we can do to improve the course. All right. And then finally, at the end, this is the slide of links. But really, there's only 4 links you need to really pay attention to. One is that overview, that course overview page. The curriculum materials are all posted online at aka.ms/MakeCode APCSP. You can sign up for professional development again at that same course overview page. And then the discussion forum, I really highly encourage you to join our forum if you do decide to teach with this curriculum. And so I'll post all of these links in the chat window as well, so you have them available for you. So I think that's it. Kelly, is there anything else you wanted to say or close out with?
I can't think of anything. Just thanks for your time. Thanks for being interested in learning about the course. We're proud of it.
Yeah, thank you all for attending this webinar. We're so excited about this curriculum. Kelly and I have put a lot of work into it, and so we would love to hear from you if you have feedback or suggestions on how we can make it better, or if you have positive examples of yourself teaching this course, we'd love to hear that too.
Absolutely.
So thanks so much, everyone.